Alright guys, we're going to do a screencast over 6.1, 6.2. This was the homework assignment, and we'll get to a couple of examples off that at some point in time. This was the front page of the homework assignment, and we'll get to some examples at some point in time on it. But generally speaking, we're going to start with some notes, and once again, this is lesson 6.1, 6.2, and it's graphing inequalities. On a number line. Okay, so a bit of review for us is that, first off, let's start with a number line. What's a number line look like? A number line should have arrows on each end, okay, and it should extend on forever and ever and ever, which is what those arrows on each end mean. So let's plot a few things on these number lines. Hopefully you have a little bit of a sense about a number line, and when I mean a sense, I mean a sense to know that the numbers to the left would be the smaller numbers, and as we move to the right, we get bigger numbers. That's one part of what you need to know. These dashes that I'm making should be evenly spaced. And notice if you leave a little bit of an error between one or another, it's not a great big deal, but you should try to keep them as even as possible. So let's plot a few statements on a number line. For example, we could have x is less than 50. Another one, we could have x is less than or equal to 6. And then another one, we could go the greater than way, the greater than side, and we'll say that x is greater than, let's do negative 14. Okay? Now, each person can number their own number line however they want. On this one, let me go ahead and start at like negative 10, then I'll do 0, 10, 20, 30, 40, 50, 60, 70, 80. And notice that each little gap jumps 10 spaces. That's why these should be evenly spaced as best as is possible. Okay, now what this gives away is that a less than only sign means that the dot going on the number has to remain open. And because my variable is on the left, in this variable that we're trying to represent all the numbers possible for this situation, okay, is less than, then we have to go with the numbers that are lower than. So whenever I shade this, I need to shade to the left because those are all the numbers that are less than 50. And that's what I'm representing on the number line. Okay, make sure you highlight your arrow on the end saying that that goes on forever and ever and ever. Next up, x is less than or equal to 6. Notice since this is a smaller number, I don't really have to show as wide a jump like I did up top. So let's say I want to start this one at, we'll go negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice on my number lines I keep spaces below and I keep spaces up top from the number that I need to actually graph or plot. And the purpose of doing that is is that it will give you a good balance to show some room for shading in your graph. Now, this sign says that it's less than or it's equal to. Now, if it can be the number, you put what's called a closed dot on there. And this closed dot means we can be equal to 6. The other sign with it says that it has to be lower than that as well. So we'll represent that situation as being lower. And we know the lower numbers are to the left. So we will shade to the left. Okay, and let's go ahead and graph the last one. Notice this time our sign flips around. It is a greater than sign, and in the greater than sign it's going to have to be larger than negative 14. So this time let me go ahead and I'll try and count by 5s, let's say. So negative, we'll go 30, negative 25, negative 20, negative 15, negative 10, negative 5, 0, 5, 10, 15, and 20. Now, negative 14 would be located between negative 10 and negative 15. It would be closer to negative 15. So I need to make sure that dot goes as close to negative 15 as it can. And then I'm going to make sure my shading is correct. Since my number is now greater than, it has to go above and above only. That is why I have the open dot, and that's why my shading goes to the right, because the larger numbers are to the right on the number line. Okay? And that's your basic of graphing inequalities on a number line. Now, what we're going to do on the worksheet is just a little bit different than this. It starts out by graphing. Sometimes you have to transfer from a number line too. So let's open up 6.1 and let's talk about a few examples. On 6.1, make this a little bit bigger. Okay? It wants you to represent the situation. So because this dot is closed, because the dot is closed, we should know that it has a variable that is equal to, and because it's shading to the left, it is less than, and whatever that number is, which is negative 3. And that's all you have to do on number 1. So notice if we jump to number 4, variable is closed, so it's equal to, and because it's going greater than, the alligator wants to eat the variable that's represented. The number is between 36 and 37, so that would be 36.5. And that's all you have to do on those. When we jump to number 5, it's the same thing, same concept. The only problem is that our variable now has something attached, and we have to get rid of whatever is attached. So this plus 7 needs to move to the other side. We know that we move those by using opposite operations. So there's your hint, opposite operations. And that hint should help you all throughout this worksheet. So when we're adding 7 on this side, to move it to the other side, we'll have to subtract 7. Subtract 7. 10 minus 7 is 3. And that is greater than or equal to A. Okay, so my variable now is less than or equal to 3. So that's going to put a closed dot on 3. And because we're representing the situation for our variable compared to our number, A is less than 3, then I need to shade to the left because it is less than or lower than. So here we would be adding 3, here we would be adding 5, here we would be subtracting 3 to solve for our variable. Let's go ahead and scroll down. Let's take a look at some of the other examples. Okay, same type of process. This one just needs set up. It says the sum of 15 and n, so that would be 15. Sum means plus, so we're adding n is less than 8. In order to solve this, we're going to have to subtract 15 from each side. And if we do that, n is less than 8 minus 15 is -7. So this is what we plot on the number line. You received a $25 gift card to a sporting goods store for your birthday. You are looking at skateboards and want to spend no more than $85 of your own money. Write and solve an inequality to find the prices P in dollars of skateboards you can buy. What is the most expensive skateboard you can buy? So, in this situation, we know that we have $25 to spend. We are going to stay under spending 85 of our own money. So our gift card plus the price of the skateboard must stay under the $85. And this should help you solve what is the most expensive skateboard you can buy. Because we're not going more than 85, we could also be equal to. And that's that for 6.1. Okay, I'm going to close out this and then we'll do a second part just to break it up and help it go online easier. So thanks for listening and hope these notes help.